Welcome to the Math Record. Today I'll be covering the ICTM Regional 2018 Division AA Precalculus. I'll be splitting this contest into two parts. This part which I will be covering number 6, 15, and 16, and then the next part which I'll be covering questions 17 and 20. As usual, I'll scroll down for all 20. And I'll give the answers at the end. So let's start with number 6. Two cruise ships leave the same port at the same time, so the angle between their paths is 60 degrees. The first ship travels at 16 miles per hour and the second ship travels at 14 miles per hour. Determine how long they've been sailing at the time they are 26.42 miles apart. Express your answer as a decimal round to nearest tenth of an hour. Okay, so we have a first ship that goes by 16, and then the second one goes by 14, but at a 60 degrees, so something like this, maybe. And then they're at a distance apart, so the endpoints is where the points are at, the ships are at, so then we need to connect those two, and that gives us our distance. Okay, so we have some kind of triangle. Now let's label our values. So we know that the angle between them is 60 degrees. And we know that the first one goes at 60 miles per hour, so the distance that they traveled is 16 times the time. And then the second ship is 14 miles per hour, so it's 14 times the time. And the distance once they traveled that amount of time at that 14 miles per hour and 60 miles per hour, they're 26.424 miles apart. Okay, so what we could do with this is that we could just use the law of cosine. So let's move this up. And then our law cosine, which is equal to 26.424 squared, is equal to our two side lengths squared. So 16t squared, which is equal to 256t squared, and then 14t squared, which is, um, it's kind of hard to tell. I'm just going to capitalize my t so then we could separate it from the pluses. Plus a 14t squared, which is a 1996t squared, minus 2 times the product of these two, which is 14t times 16t times the angle between them, which is cosine of 60. Cosine of 60 is 1/2. So then we can cancel out the 2 and the 1/2 to make 1. And now we can just use our calculator to simplify this part. So 256 plus 196 minus 14 times 16 will gives us 228t squared. So to get our answer, we just have 26.424 squared divided by 228, and then take the square root of that, and we get a t that has 1.7 hours. And that's basically it. Okay, so that was for number 6. Now let's go to 15. Line A has slope 3/2 and line B has slope 4. Line L bisects an angle formed by A and B and has a positive slope. That slope can be rewritten as K plus W squared P/Q, and then add the coefficients. So basically, we have a slope that's 3/2. So let's say something like this. And then we have a slope that's a 4, so something like this. Okay, so let's label this. So this is line A, and this is line B. And then there's a line L that bisects the angle. So we have a line L. So let's make this one red. And it bisects it like something like this. Okay. And that is our line L. So, or I could just write it in that form that they gave us. So the slope can be rewritten as this form. So let's think about this. If we have a, and I'm going to put it in vector form, because usually when you have angles with lines, you like to use vectors. So the vector is going to be the change in x and change in y. So the change in x for 3/2 is 2, and the change in y is 3, because rise over run, right? And then b, which is 4, the change in x is 1, and the change in y is 4. right? So slope of 4 over 1 and 3 over 2, right? So if we want to get the slope of line L, let's just call it our x and our y, right? So it'll be y over x will give us our slope. So now we just need to look for this value. So how do we do that? Well, there's actually a really neat formula when working with vectors, and we could call this theta, and this is also the same angle, so this is theta. The formula is that cosine of theta is equal to the dot product between those two lines divided by the magnitude of those two lines, basically. So how do we do that? Well, that's magnitude of b, sorry. So it's actually pretty simple. So we know, so let's focus on line B and line L. So cosine of theta is equal to 1 times 4, 1 times x, which is x, and then 4 times y plus 4y. So that's just a dot product. Multiply your change in x's, multiply your change in y's, and add them together. And then divide by the magnitude of both of these. So the magnitude of this is 1 squared plus 4 squared, which is 16 and 1, that's 17. So square root 17. And the magnitude of x and y is x squared plus y squared. So square root x squared plus y squared. Okay. And now let's work with line L and A. So cosine of theta is equal to 2 times x, which is 2x, and then 3 times y, which is plus 3y, over our magnitude over our L and magnitude over A. So that's 4, and that's 9, and that's 13. So that's 13 times square root x squared plus y squared. So now we don't need that diagram anymore because all we have to look for is y over x. And we had to do some math. So basically we know that the angle are the same, so we could set them both equal to each other. And I noticed that they both have the square root x squared plus y squared on the bottom. So I'm going to divide them out. So we have x plus y, x plus 4y square root 17 is equal to 2x plus 3y over square root 13. And then we could cross multiply, so we get square root 13x plus 4 square root 13y equals 2 square root 17x plus 3 square root 17y. Okay, so we're going to combine like terms. So then our x goes with x and y goes with y. So that 2 square root 17 minus square root 13 times our x is equal to 4 square root 13 minus 3 square root 17 times our y. And remember, we're looking for x over our y over our x. So our y over our x is equal to 2 square root 17 minus square root 13 divided by this, which is 4 square root 13 minus 3 square root 17. So now all we have to do is simplify that number. So we could just multiply the numerator and denominator by 4 square root 13 plus 3 square root 17. 4 square root 13 plus 3 square root 17, right? So then 4 times 4 is 16. So I'm doing the denominator first. So 16 times 13 minus 3 times 3 is 9, and then times 17. So that's on the bottom. And then on the top, we have 3 times 2, which is 6, times that 17. So 6 times 17. And then negative square root 13 times 3 square root 13, that is minus 3. Oops, sorry, 4 square root 13. So that's minus 4 times 13. And then the final term is 2 times the 4, which is 8, times square root 13 square root 17. And then negative square root 13 times the 3 square root 17 to make negative 3 square root 13 square root 17. So this is coefficient of negative 3. This is a coefficient of 8. So this one's a plus 5. Square root 13 times 17 is at the radical. And now we could just use our calculator to simplify. So 6 times 17 minus 4 times 13, and we get a 50 plus a 5 square root 13 times 17, which is 221, over 16 times 13 minus 9 times 17, which is 55. And then we could divide 5 from the numerator and denominator to get 10 square root. Since we need a coefficient in front, we just put a 1. So 10 plus 1 square root 221 divided by 11. So now we see our four coefficients, so add them up. So 10 plus 1 plus 221 plus 11. And you should get a value that is equal to 243. Okay, so that's our answer for 15. Now, number 16. Let T be a tetrahedron bounded by the point 0, 0, 0. So let's kind of draw our picture first so we get an idea of how this looks. Then we have something like this. Okay, so I usually like to label this your X, your Y, and the Z. So then it's facing towards you and see how it looks. So we have 0, 0, 0, 0, 0, 8. So this is at 8. And this is at 0, 6, 0. So this one's at 6. And we have 10, 0, 0. So this one's at 10. And this is a tetrahedron. So let's connect the points. So something like this, this, and this. Right? So we have this tetrahedron. And a unit vector v normal to the face of the tetrahedron contains the points 0, 0, 0, 0, 6, 0, and 10, 0, 0. Can be written as this form, and then find the sum of the coefficients, basically. So we have this face, so let's just kind of color it a bit. So we have this front face that's facing us, and there's a unit normal vector. So let's make it blue. So we have some kind of unit normal vector. So this vector is perpendicular to this face. So it doesn't have to be here. It could be like here or here or here. It doesn't really matter because they're all going to be the same vector because the change in x, the change in y, and the change in z are the same. So it's just that it's at different positions. So, but the changes are still the same. So it's going to be something like this, and it's going to be 9. So kind of really hard to see, but something like this. And it's 90 degrees to the plane. So it's 90 degrees to this plane. So how do we get this vector? Well, first we need to get this plane. So how do we get this plane? So if you think about it, have you ever seen the equation like 10x plus 20y plus 30z equals like 60? I'm just using this as an example. Your x-intercept is going to be 6, your y-intercept is equal to 3, and your z-intercept is 2, right? It's kind of like matching like how these things work, right? Sorry, that one's not that. It's just so your z, your y, and your x, right? So it's just like that. So we're going to have to make an equation like this. So what we do is that we have to look for the LCM of 8, 10, and 6. So 8, 10, and 6. So this is 2 times 5, this is 2 cubed, and this is 2 times 3. So we need 3 2's, a 3, and a 5. So that's 8, that's 24, that's 120. So our LCM is 120. So our equation is 120 is equal to, for our x, we divide by 10, so that's a 12. For our y, we divide by 6, so we get 20. And for our z, we divide by 8, so we get a 15. And now we got our equation. And a good property about our equation is that the coefficients are equal to your normal vector. So your normal vector is 12 by 20 by 15. So how do we get it into a unit normal vector? Well, basically, if you do the magnitude of this, this is 12 squared plus 20 squared plus 15 squared. Take the square root. That is our magnitude. For a unit normal vector, this magnitude has to equal 1, but this is not equal 1. So what we could do is that we could just divide this entire like vector by this magnitude so it becomes 1. So it'll be 12 divided by this number, and we could just put it on a calculator. 12 squared plus 20 squared plus 15 squared, which is equal to square root 769. 769. And that is our unit normal vector, 20 over 769, and 15 over square root 769. And that is our unit normal vector. So we know what our x, y, and z and w is, so add them together. So 12 plus 20 plus 15 plus 769, and you get an answer of 816 for our number 16. And as promised, here are the answers at the end. And for the next video, I'll be answering questions 17 and 20. Thanks for watching.